Hi everyone, I'm Vrushali Gajare and I'm from Bharati Vidyapeeth College of Engineering for Women. Currently, I'm studying in final year and today I'm going to demonstrate my DMW mini project, which is IPL first innings score prediction. I've implemented this project by using lasso regression. You can use any regression like linear regression also. I also tried to use linear regression first, but the accuracy was not very good. So I used regularization with it, that is lasso regression. So to understand my project, first let us look at the terms like underfitting, overfitting, and regularization. Um, so, for example, take a case of where we are trying to predict the number of matches won based on player's age. So, the as the age increases, the number of matches won decreases. Therefore, we can build a linear regression whose equation will be like matches won is equal to theta 0 plus theta 1 into age. As you can see, the line is passing through very few data points. That is, this model is not very good at generalizing the data points. Here the data points are going away from the line. That is, this line is trying to find the best fit. If in the future a point comes, data points come here, it will not be able to predict the number of matches won very accurately. So we can build a model which looks something like this. In this model, the line is passing through each and every data point, and in this case, our equation will be might look like this. So it's a higher order polynomial equation where we are trying to find the matches one based on the age of a person. But here the issue is the equation is really complicated. This line is zigzag, which is passing through all the data points, and it is not generalizing the data, uh, and it will try to accommodate the noise also. What might be better if we have a line which is like this. So, this is the balanced case between the previous two cases we saw. The equation is also fairly simple. The line will look like curve and it can generalize really well so that if tomorrow a new data point comes in, this equation will be able to make better prediction. So the first case we saw was of underfitting, the second case we saw was overfitting, and the third case we saw was the balanced fit between underfit and overfit. So here you get a better idea of overfitting. That is, if you try to run training too much and try to fit too much to the training data set, then you will have issues with the training data set, testing data set. When you try to predict your new data point, it might not do better prediction. So now our goal is to reduce overfitting. How to reduce overfitting? So here is my overfitting line along with the equation, and in this equation if somehow I make my theta 3 and theta 4 almost close to 0, then I can get an equation like this. If theta 3 and theta 4 are almost close to 0, then we are kind of ruling out this whole factor, and then we can get equation like this. Hence, the idea is to shrink the parameter, that is theta 3 and theta 4. Now, the question is, how do we do this? So, in order to achieve reducing overfitting, let's look at mean square error. This mean square error is used in linear equation. We calculate mean square error when we run training. We pass first sample and then we calculate y predicted on some randomly initialized value. Then we compare it with the truth value, and this is how we calculate mean square error, that is MSE. So this is the formula to calculate MSE, and the term in the red here is actually y predicted, which can be expanded like this. Now this is the higher order equation, and in it x1, x2 and x3 are the features. In our case, that is age. This MSE is used in training and we want to minimize this mean squared error. So how about in this equation we add this red term, that is lambda summation of theta I square. Here Lambda is the free parameter and you can control it. It's like tuning knob, and here we are making square of the theta term. So now if your theta gets bigger, this term will get bigger and hence our error will be bigger and your model will not converge. So here we are penalizing the higher values of theta. Whenever the model tries to make theta higher, you are adding a penalty here. Hence, by adding this penalty, you are making sure your theta value doesn't go higher. And it depends on this parameter lambda. As I said, this parameter, a lambda parameter, is free parameter. That is, we can set its value on our own accord, also known as hyperparameter. You can find this theta or tune this theta. You can find this lambda or tune this lambda. If you make this bigger, then the value of theta will get smaller and smaller. And if you make this lambda smaller, the value of theta will get bigger and bigger. So by adding this term, we ensure that our theta values are not too large. And as we have used here theta square, this is L2 regularization, which is known as lasso regression. So in the place of theta square, if we use mod values of theta, it is called L1 regularization, also known as regression. So here, now we have understood all the terms. We will go to the code. So in this, first I have imported all the important libraries, that is pandas, pickle, seaborn and matplotlib. So the first step in any project is to load the dataset. After loading the dataset, second step is to explore the dataset. In order to explore the dataset, I have printed the head value of the dataset, that is first 5 rows. Now, what are the columns in dataset? We can see clearly, that is mid, date, venue, bat team, ball team, batsman, bowler, runs, wickets, over, runs in last 5 overs, wickets in last 5 overs, striker, non-striker, and total scored that was scored in that particular match. Similarly, I have printed the tail part of the dataset, that is last 5 row of our dataset. Next, I have printed the shape of the our dataset. That is, there are total 76,014 rows and total 15 columns. To know our dataset better, I have printed all the columns which are present in our dataset. Next, I have printed data types. This can help us to recognize that what type of data we are actually processing. As you can see, most of the data types are either object or int. Only one data type is float, that is overs. So next step in our project is data cleaning. That is, we need to clean the data before processing it or using it for our model. So in data cleaning, first we are checking for missing or null values, which can be done by df.isNull.sum. As you can see, all the values are 0. This means that there is no missing values or null values. Next step is removing unwanted columns. Now the columns mid, venue, batsman, bowler, striker and non-striker is of no use to this project. So I have removed these columns, and I have printed that before removing unwanted column and after removing unwanted column, how many columns are there. So before removing the unwanted columns, total 15 columns were there, and after removing unwanted columns, there are total 9 columns. And I have printed the columns which are remaining. Again, I have printed the head value of our dataset. Now you can see our dataset has shrunken to only 9 columns. Now the next step is we are keeping the only consistent team. As you know, over the years, many teams were added, like Rising Pune Super Giants, Gujarat Lions, Pune Warriors, which are not playing right now. So we don't need all the teams which are not playing right now. So we are going to remove this unwanted teams and keep only consistent team that were from beginning to the till now playing. So the consistent teams are Kolkata Knight Riders, Chennai Super Kings, Rajasthan Royals, Mumbai Indians, Kings 11 Punjab, Royal Challengers Bangalore, Delhi Daredevils, and Sunrisers Hyderabad. So I have printed that before removing and after removing inconsistent teams, what is the size of our data set. So before removing, as I have told above, there are total 76,014 rows, and after removing inconsistent team, there are total 53,811 row. Uh, then our next step is to remove the first 5 overs of data in every match. You might ask that why I have done this. I have done this because to predict we have some value. We need to take some input from a user. So here we are going to take input of the first 5 overs, that is runs made in first 5 overs and wickets taken in first 5 overs. Therefore, we do not need this information and hence we are removing it. So after removing it, we are left with only 40,108 rows. Now we are converting the column date from string into datetime object. As you have seen above, the data type of the date is string, but we need to convert it into datetime object so that we can use it. To convert it into the datetime object, I have imported datetime from datetime library. The next is I'm checking the correlation of each feature. That is, each feature is related with other feature on how much scale. So as you can see from this plot here, 1 is highest correlation and minus 0.4 is the lowest correlation. Now every feature is highly correlated with itself. Other than that, you can see run is highly correlated with overs, that is 0.88. That is the scale on which it is correlated. So here you can see all the correlations between different features. Next is data pre-processing. So you can see there we have two columns, that is ball team and bat team, which is not categorical feature. So to convert it into categorical features, I have used one hot encoding method. After that, it will be converted into categorical features. After that, I'm rearranging the columns so that it is easy for me to visualize the data. And I have printed the encoded data sets head. So you can see now all the data is in 0 and 1 forms, which is easy for the computer to read. So the next step is splitting the data into train and test set. As you can see, our data set consists years. That is, the IPL is conducted each year starting from 2008. So we are going to split the test and train data set based on the year, and it is time series type of data. So in train data set, I'm taking all the IPL data of less than equal to 2016 year, and in test data set I'm taking all the data greater than equal to 2017, that is from 2017 to till now will be our test data set. So after splitting the data set, there is no use of the date column, so we are removing the date column. Our After data pre-processing, our next step is model building. So as I told, I'm using the lasso regression here. Hence I've imported lasso from sklearn.linear model, and I've used here grid search cv, which will help me to find the best value of lambda, which is here is alpha. So I have given some values in the array here for our lambda. You can see this value range from 10 to the power of minus 15 to 40. That means in this value the model can take any value, decide any one value for our lambda, and it can tell us. So here I have passed all these parameter in the grid search cv, lasso, this parameter, and scoring is the method used, which is used to score our model. So I've used negative mean square error, and cv, that is cross validation, equals to 5. So and next I have fitted my train data set. After fitting the train data set, I can get to know the best parameter and the score of our model. After running here, I got that our alpha or lambda is 1, and our score is minus 320. Minus 320 is pretty good score, and hence I'm going to use this model. Uh, Next, I have here did prediction lasso regressor dot predict. I have now predicted all the x test values. In regression methods, there are some metrics used like MAE, mean absolute square, MSE that I have told in the presentation, mean square error, and RMSE, root mean square error. These are the metrics which are used to evaluate our model, and hence I have printed it. These are 12, 262, and 16. These values are pretty close to 0, so I can. This means that my model is good and I can use it for prediction. Now I have imported pickle so that I can save my pickle this model and use it later. So I have saved this file as .pkl file and I have dumped it. uh, so next, now this is my backend, um, and this is my front end. Here, the front end is I have developed with the help of HTML. It is pretty self-explanatory, so I'm gonna scroll. Here, first I have added the CSS file, and I have added the favicon. That is the symbol that you get in the browser when you open a new window. And here, I have, with the help of class, I have uh, division tag. I have used different division tags and created animated animation type effect, and I have used all the banners of all the teams. After that, there is a short form where the user have to submit the information of the first 5 overs and like batting team and bowling team so that we can predict it. That's pretty much. I have written it again because this again here because the animation is on the both side, that is on left side and right side. And this is my app.py. Here I have integrated the front end with back end with the help of Flask. So I've imported Flask here, and now I've loaded the model that I saved in the notebook, and I'm loading here regressor hour, that is lasso regressor. And here from the HTML page, this app.py will take all the required information, that is what is batting team and bowling team. So for batting team, as there are total 8 teams, so I have also used here one hot encoding, so it will be it will be easy for the computer to understand that which team is actually batting team and which team is bowling team. So after batting team and bowling team, I have taken overs, runs, wickets, runs in previous 5 overs and wickets in previous 5 overs. After taking all these inputs, I have entered it in a temporary array and passed it to the regressor so that it can predict the data. So now I will show you the demo. I will run the code. I'll copy this and paste it here. So this is the front end here. Now, as you can see, we have to select a batting team. So I will select Mumbai Indians, and bowling teams I'll select Chennai Super Kings. So it is here telling us the to input the over, that is the current over. I am gonna give something like 8.3, and total runs scored till now. So I will enter it like 76, and wickets total taken. So wickets total taken is 4, and runs scored in previous 5 overs. That is, it will predict on based of previous 5 overs. So runs scored previous 5 over cannot be greater than the total runs scored. So we will give something like this 54, and wickets taken in previous 5 over will take it as 2. And then I will click on predict score. Then it will give us the score that Mumbai Indians is going to score. That is The score will be in the range of 154 to 169. Uh, so that's all for my DMW mini project. I have to tell you that I got to learn a lot about uh, all this with the help of this project. I think regardless of which year, in which year you are, mini projects are very, very important because it keeps our learning up to date, and it is also good for our resume. So I think everyone should do mini projects, whatever may be the topic, whatever may be the subject, but doing mini project is very, very important. Thank you.